So for those of you who don't know me, I was referenced earlier. My name is Lindsay Hooper. I'm one of the coordinators for this event. And my job here as the moderator is simply to keep the train on the tracks. So I think we should start by saying thank you guys. Those were both awesome presentations. I feel like I really understand what you guys do now. I'm sure I understand the nitty-gritty. But to kick us off here, we'll start general and then go more specific. Put simply, what's the connection between Magic and foam? Why does it make sense to have both of you here at this one event?
I mean, I think actually, what we were initially putting together, I don't know if I thought there would be as big of a connection as I actually believe there is now, right? Big thing is for Magic to work, a significant input into our proof of availability that we would want to use is a proof of location. So when you think about one of the issues with proof of availability, which is like I can set up a hotspot and I get paid for it, being able to spoof hotspots is a real problem. If we can prove their location programmatically, that's really, really valuable. I also think, at the end of the day, Magic is focused on internet connectivity, and foam is basically focused on something analogous to GPS, right? And I think these are two core components of most IoT applications.
Oh yeah, I would say we're focusing on one singular problem of this accurate time and location proofs, and the idea is for other synergistic protocols to hook in and build with that. But I would say some other similarities are, people are really enthusiastic about something like Bitcoin or Ripple, but you can't really do much except go on Twitter and tweet, "I love this thing." Where in our projects, it's also, there's an aspect of decentralized infrastructure and community building, so you have people actually installing things physically and potentially, coming together as groups. And I think other similarities are just this idea of kind of taking on the way things are structured today just by opening up this new permissionless way people can join projects.
Cool. Great. So you just sort of referenced decentralization. Can you talk to me a little bit about how, from both your perspectives, so I suspect it might be similar, but you might have some differences. How is connectivity changing at the end of the day due to decentralization? Anytime, go crazy.
Yeah, I would say that I think even just a few months ago, the New York Times ran a huge expose of how your location data is being abused by applications and telecoms without you. It was revealed telecoms were selling location data of customers that easily ended up in the hands of bounty hunters, and all these other applications that even when you think you have GPS off is actually logging your location and selling it on marketplaces. So one, that's scary that people are tracking you and selling that data, but two, you don't really get any cut of that either. So here in this kind of new decentralized way, it's like privacy and agency is first. So as a customer in our system, you have the choice of when you want to generate that proof, but you also have the choice of when you want to reveal it to someone else. And it could very well be that you reveal it to an aggregate marketplace and you sell your own data, but you at least have control over that.
Yeah, and I think from a high level, my view would be that, yeah, certainly you get more agency over your connectivity if you're starting to participate in these types of decentralized networks and of your data as well. But then also just from a higher level, right, we're sort of entering this world, especially as 5G starts getting rolled out. And even there's marketing hype starting to talk about 6G and crazy stuff like that, which is definitely fake, but at least for now. We're really entering a world of just completely ubiquitous connectivity. Optimization around that or how you access those networks is actually going to become increasingly important. There's only so much spectrum to go around. It's like a limited natural resource. So that's something that I think is really interesting. We're almost entering this late stage connectivity concept. Yeah.
Can you unpack that a little bit?
Well, it's just for a long time, there was internet that was wired and now it's not wired and it's still sporadic. But I think we have we always have this idea of ubiquitous connectivity or internet everywhere, which is a fun thing to say, but the reality is it's becoming true, right? Where, at some point maybe you have satellite Wi-Fi in the middle of sub-Saharan Africa. And so what does that look like, right? What does it look like when you have the ability, not just for large companies, but smaller people to also participate in this? What does it look like when you have a more competitive marketplace because you have all these different technologies coming out, right? Like putting aside 5G and things like that, right? Like if Elon Musk actually succeeds in launching his space satellites, right, like it's going to change quite a bit. So that would be like the idea of late stage connectivity, I guess.
That's great. So you kind of talked about wired versus not wired there. You touched on it. How does this sort of decentralization, how is this going to affect like the physical things associated with connectivity?
Yeah, I mean, I think when it comes to physical devices, I think the big thing, right, is like right now, there's actually a lot of hurdles to jump through to get a thing connected to the internet. When we're talking about IoT, if you're dealing with Wi-Fi, then you're shipping a Wi-Fi product, you have to get your end customer frequently to input their credentials. It can be like a painful setup sometimes. If you have a device that's Bluetooth, it has limited connectivity, right? It's only when the Bluetooth pairing works. If you have something that's cellular, it can work on some networks, sometimes not all networks. It depends on what you're doing. And you frequently have to engage in a lot of technical things to do that. Moving to a world, right, where ideally these physical devices can just obtain connectivity. It's not a thing that you have to think about. Even unpacking like a connected Keurig machine, it just connects to the internet. You don't have to set anything up.
Yeah, I'm not so sure how much the foam protocol would impact like the design of actual things, but it would definitely dramatically affect the kind of architecture of IoT and devices. And what I mean by that is like when you look today how geolocation is done on IoT even without GPS, it's kind of this whole flow of data that's going to go from the field and ultimately into AWS, Amazon Cloud, or some other cloud service. And when they actually do the geolocation, it's all about like uplink. So you're going to take all this data, put it to the cloud. The cloud's going to magically tell you your location and then send it back out. And with us, there's no cloud, and it's like kind of about downlink so that you're going to get the signals and be able to do the stuff there, kind of how GPS works. And ultimately, there's no cloud either. So when we speak to a lot of IoT potential partners or just people in the space, and we try to explain what we're doing, it really kind of like cuts into their whole market research because they're like, no, it's going to go into the cloud. And we're just like, no, it's not.
Great. So how does all of this sort of affect the various stakeholders in the infrastructure?
I would say at least in foam, it expands like the set of stakeholders pretty dramatically. Right now, these global satellite systems are only really capable to be pursued by nation states. So we have GPS here, Galileo in the EU, there's a Chinese one, Russian one. And for even one business to go tackle, that's kind of huge. But here, the only real way to kind of go about it, other than being a nation state, is actually have a way for people to kind of participate in mass. And so that's where we're really going, where you could have one company like mine that's kind of spearheading it, but then you have these network effects where people can build in over time, and you don't have to start from being like a nation.
Yeah, and our general view, right, is that anyone who's a stakeholder currently in connectivity should be should be able to participate in something like Magic, and it just sort of broadens the set of people that can participate in this type of business. I think what's interesting, right, is you could imagine a world where you have large swaths of connectivity provided by larger companies, but then you have places where there's dead zones, and you have someone setting up a Wi-Fi network to cover that, and then actually selling that back into the network in terms of like a wholesale situation. So this is actually something that exists today in cellular in the form of like I think it's going to be called agile networks, or it might be another one or two out there. But they basically will set up small cell deployments or macro cells on apartment buildings in places where there's no coverage or where there's dead zones, and they'll wholesale that coverage back to T-Mobile. So there's this there already is this like very complex marketplace of carrier interactions and third-party interactions for obtaining connectivity. Our hope with Magic is that it just makes it easier. And in a lot of and the people who have gone through the effort of rolling physical infrastructure, actually are able to be compensated in a more transparent and fair way for it.
Yeah, I also just want to unpack the word stakeholder a bit, because when we actually tokenize protocols, it actually kind of expands what it really means to be a stakeholder, because in these kind of blockchain software-based projects, you need this token to access it. But that token then also gives you necessarily rights. So you're like literally a stakeholder in that protocol and how it may develop or change. And a lot of projects, including Foam, have like voting systems or governance. But you're also a stakeholder in that if you don't like what's happening, because it's open source, you can just take the code and restart the system as well. And we've seen that happen in different projects. And so like the word stakeholder really kind of takes on a new meaning when you introduce this kind of tokenization.
That's great. So I feel like that was a really big answer between the two of you, which is fabulous. One of the things that I'm most interested in personally is, you said that this marketplace is already pretty complex and that, the word stakeholder can mean a variety of things at this point. How will, companies like Magic and Foam affect the consumer perspective? Like for me, using your products, how aware am I going to be of all of this kind of going on in the back end?
I think ideally with Magic, right, it's this type of thing that at scale you shouldn't really have to know a whole lot about it. You should just kind of have connectivity. And if you want to, if you're building a new device and it needs connectivity, you ideally are writing a snippet of code. It's like basically calling an API, and you're able to access networks as long as you have the correct modem or radio access technology in your hardware. So it should be, in our view, it should be relatively unintrusive.
Well, we're very explicitly a protocol, and like when we look at Web 2.0 today, probably majority of web users don't know what HTTPS is or SMTP or TCP/IP. So Foam's a protocol that that applications can hook into and take other modular building blocks in the blockchain ecosystem. So we would imagine that these applications are ultimately really user friendly and hiding these kind of protocols in the same way our technology does today.
So it sounds like you guys are saying that you almost don't have to be visible in a lot of ways. Is that correct?
In like kind of the end product, but obviously in this stage or the next stage or the next, you have a different kind of visibility because people can actually be like protocol workers and participate. And most people can't participate in GPS by running a satellite. So like you have this kind of awareness of the people who may become like a deeper participant, but then when you have these like consumer facing apps, it should be abstracted away.
How common is it to encounter somebody who is part of one of these protocols right now? Do you think they're in the room, or do you?
Yeah, I do.
You do? That's great. Is anybody involved at this point? Ajay is. That's great. Okay, so speaking of protocols and all of that, can you kind of unpack sort of the tech under the hood a little bit from both Magic and Foam for me?
I can literally unpack it in that. For us, we rely on these consensus systems as part of blockchain, and for us, we use like 3 different types. This will be technical, but there's Byzantine fault-tolerant consensus algorithms. They come in like 3 different flavors: synchronous, asynchronous, and partially synchronous. And so our system that is both local and global uses all of them. So we have a synchronous fault-tolerant protocol over radio, and then we're using these low-power radios that I've described. And locally, they maintain that consensus from the radio information using Tendermint consensus, which is a blockchain proof-of-stake algorithm. And then from there, we use scaling solutions like Plasma to basically communicate back to a main blockchain. And that main blockchain uses like asynchronous consensus. That is means it's slower but more secure. So under the hood.
Yeah, and we're at an alpha stage, so we're not quite as far along as Foam is, but so my answer isn't going to be quite as complete. But basically, we've got we're basically running a system that allows you, that's based on OpenWRT, and so you can, any OpenWRT router, you can take our code, it's open source, and fork it and have it basically just loaded up as a way to create an access point. Next thing that we're rolling out will be micropayment channels. So that way you can actually transact on a test net and see, okay, hey, I set up a node, it's talking back and forth. And then we still have a lot of work to do, to be totally honest, in terms of building out, what would a proof of availability look like? How would how would it reward people for setting these things up. And so I actually think this is a moment where it's super exciting to come on and take a look at it and poke holes in our open source code. At the end of the day, from a tech perspective, we will end up probably somewhere fairly similar in terms of relying on something like Ethereum to manage the consensus for us and having like an ERC20 compatible token in the form of Magic. But right now, it's pretty experimental and just sort of running on OpenWRT routers. We'll probably have an SDK as well for mobile fairly soon.
Do you think you guys are benefiting significantly from being open source at this point, from getting a lot of holes poked? Do you have any good stories?
Yeah, no, I mean, no good stories, but I think it's, I will say that I think in general, and Hologram as well is strongly biased towards open source. We did a lot of open source hardware previously. I think open source is a really, really powerful tool, just from the perspective of, not just making your code auditable, but also being able to engage a community and allowing them to really help with the development and have them own it, right? So even though Magic is really young and we don't have a huge community right now, we still have people who are active and answering, doing issue pulls on GitHub and actually bugging us about stuff. Sometimes in languages we don't know, but yeah. So it's I find open source to be an extremely powerful tool in general, both in crypto and in IoT and general tech.
I can only echo that.
Only echo. That's great. So we've actually moved very quickly through a lot of these questions. Is there anything else before I sort of turn the mic over to the audience? Because I know there are a bunch of questions that people had from earlier. No? Okay, questions.
Thanks much. You guys are clearly leaders in this area and applying a number of different approaches to solving big problems. I wanted to ask a Magic question, only because I think you mentioned it just once in passing. I think I saw a parking meter, and I heard one reference to micropayments. If you can just expand a little bit about micropayments, using perhaps parking meters as an example, or perhaps as broad as you'd like to go with that.
So micropayments are important for Magic in the sense that mainly for mobility reasons. So actually, parking meters are sort of actually almost a very bad example because they're fixed, and it would just be like highly likely talking from one network to another network. And when that's happening, you might be able to true up, and you're going to just transact on chain. And so I guess to back up for a second, like the big problem with lots of very small transactions is that you're going to incur, at least since we're building on top of Ethereum currently, you're going to incur a lot of Ethereum fees every time you go to settle up on chain. And those fees are going to be oftentimes greater than the transaction themselves if it's a very small transaction. So if you have things that are moving between networks, then you need to provide some sort of mechanism for truing up payments in a way that's not going to be cost prohibitive from like a gas or fees perspective. That's the main idea behind micropayments. For us currently, we're building out a micropayment channel solution where we have like a payment enabler that allows you to aggregate payments and then settle up. We could envision using something like Plasma or something like that as a scaling solution as well, or the Raiden network if that starts functioning. But for now, we've just thought of it as, hey, if we want this to be a network where you actually have mobility, that meaning that you are hopping from network to network, then we need to provide some sort of base level way for you to do really, really small transactions without incurring massive fees doing it. Thanks. Yep.
I'm coming.
Hi. So I actually see a very strong connection between Magic and foam. I work for a IoT ag tech sensor company. Our devices connect over LoRa, and they connect to LoRaWAN gateways that are then backhauled over hologram SIM cards. So there's actually like a lot of this going on. But yeah, so I guess that's kind of my question is, do you guys also see that collaboration where, I mean, I'm envisioning a LoRaWAN gateway being capable of being what did you call it? A node zone anchor. But that zone anchor also has to communicate to the internet at large, I assume for the blockchain transactions. And that backhaul could be provided by Magic, right? So putting out a zone anchor could be as simple as like having a zone anchor that's already provisioned for the Magic network, and you just provide power, and now you have better location accuracy.
Yeah, I mean, I think that sounds cool.
Yeah, I'm not sure where the question was, but definitely a way that definitely possible to do. We imagine like we're pretty agnostic on everything, so it could on what software the radio ultimately would run on. We think LoRa is a really awesome candidate. We're also agnostic on how they would get their connection. They could use like Ethernet connection. We have this concept of like zone authorities and zone anchors. So you might have endpoints that subscribe to a gateway to get it out, but then that gateway could be subscribed to Magic. And it really could, each individual zone could have their own configuration, and that then would influence how they want to charge their customers based on what kind of actual overhead they have.
Questions from this side of the room? Oh, right here.
Actually, yes, I have a question for Magic, and two questions actually. I assume that the service provider, in terms of their bandwidth and their technology, would have a huge problem of opening up their bandwidth to a lot of people for share use. And also, like in this case, how do you deal with that? And also, what if there's case one person will completely flood the network? How do you actually prevent that? Because once you open up the network, anyone can actually do anything to it.
Yeah. So I think there's two things there. So like, so one is sort of how service providers would think about Magic. I think that there's, it's sort of case by case basis, and some people, I think are more receptive to it than others. I think that our intention, right, is not to build something that disenfranchises those people, though, and so it's something that we're open to collaborating on. There is this thing as well where if you really think about it, right, like you could build to a certain extent if you're interested in doing this type of thing professionally, right? Like you can build your own ISP. Like it's not an undoable thing, and so those are kind of the initial targets for Magic. People who are interested in taking this more DIY approach rather than just sort of like opening up the floodgates for other networks that are out there. The other piece is just around access control. And so this is something that we would envision. So right now, I mean, there are already kind of safeguards around that in terms of how you connect to things. You could easily set like a service level agreement via smart contract. So when someone connects into it, it's like, hey, you're allowed to do this. It's going to cost you, 10 Magic tokens or DAI or whatever you use. And you're going to get 10 megabytes up, 10 megabytes down, up to 100 megs. And if you, do something crazy, connection gets shut off. So we would ideally have programmatic access control that would allow you to do that. And over time, I think a deep future state of it would be you have sort of like a reputation management system where you can intelligently predict which types of devices and networks are going to be good actors and bad actors. But that's sort of like a holy grail thing in like blockchain in general. Well, it would just be anything that violates the service level agreement, right? So I think it's, for some devices they pass 1 meg, some devices need, to do 7 gigabytes. Actually, to be honest, it's typically not the passing of data that creates major issues. A lot of times it's doing funky stuff at the signaling layer that can create a lot of issues. And so because Magic actually at its core is an authentication protocol, we should be able to prevent a lot of that.
I think I saw a hand over here. You're welcome.
So, earlier when you were talking about the building the app thing, like you mentioned, the Pokemon thing. Yeah. Like you mentioned, building an app from the new thing that I saw,
I can try to answer. Just basically, the idea is like in Pokemon Go today, like spoofing is one of the biggest things people do. So like there's all these communities of people trying to fake their GPS so their character can run around the world, and the game is always stopping them. That's cute, but on like the actual business side, Niantic, which is behind Pokemon Go, they lost all this business revenue because they wanted to partner with like the places people went and get a cut of revenue of those stores. But because everyone's spoofing about that, they don't actually know if people are buying anything at those stores because of the game. And so like they lost out on this whole business model. So
hold on. I'm sorry. So yeah, but right. So I know it could be, I know how the Pokemon Go is like, sometimes it could be dangerous and stuff, accidents and stuff. I'm a fan of Pokemon, but I don't have to go up, but I'm only a fan of the versions. Sorry, I'm a fan of the handheld versions and as well as the show. Gotta catch 'em all, Pokemon.
Thank you.
Hey, good evening. Great presentations. Thanks, both of you. On the Pokemon Go end of things, as a side note, my 14-year-old stepson says the reason they're not making as much money is because it's now lame, because old people like me are doing it. But anyway, that aside, I come mostly from the industrial IoT end of things. We have a software stack, but on our end of things, when we put up a slide deck, like the third slide always says, you don't want to do this because of security, and let me explain why we fixed that problem. So let me turn it around now. You have to answer this question. Security is a big problem. Yes, the location stuff is great, but what if you get like an organized mob of what do you call it, soprano type nodes that come in and overwhelm and now say, okay, we're going to sell this Pokemon Go bad location data, but really good location data. And I mean, what do you have in place for that? I mean, security is really the big question.
I think it's really around incentive alignment and having to even join the network, you have to put tokens up for collateral. So like what Bitcoin really proved was that it's always going to be more profitable to act honestly, and to attack the network, you're going to wind up losing money. And so you have this all these people that should be competing against each other and trying to cheat each other actually wind up coordinating together. So to even be a zone anchor in Foam, you need to put up this collateral. And as soon as you start attacking or cheating, and if you could be found out, you're going to lose that collateral. So as an attacker, you're going to have to weigh basically the kind of capital you're going to put up front and what kind of reward you think you're going to get. And if you ultimately try to steal tokens and attack the network, you're basically destroying the value of that network. So the tokens you just stole, quote unquote, are now worthless. So it's a kind of trying to find this balance between punishments and rewards, and having people actually have to have skin in the game to even participate, even if they are a bad actor.
I think,
you want to add?
I think we have time for, oh, go ahead.
That was good. I agree.
I think we have time for like 2 more questions, so.
Yeah, hey guys. Yeah, thanks for the awesome presentations, both of you. There's definitely a lot of nuggets to take away from. So I actually have 2 questions, one apiece, if that's okay. Or, okay. All right, so yeah, the first one is to you, Ben. And I'm just trying to get like a high level, like a big picture of how like Magic fits in the overall like tech architecture. So like at least today, like from how I see it, like we have the bottom layer, which is like the physical connectivity layer, from like the like cellular tower, small cell, like LP WAN, 4G, 5G, and then after that will be the like the data transport layer. And so my question is, do you see like Magic as like a layer above the transport layer as a way to kind of make the like data, how you transport the different data, more intelligent and automated, like from between the different ISPs, for example?
Yeah. So I think it's so I would view Magic as, like, in concrete terms, right? Like it's really a piece of software that's generalizable. Right now it works on very select number of routers, and the idea is to expand that. And that piece of software effectively serves as an authentication layer. And so it's not necessarily like reinventing the transport itself. Like, you're still transporting, potentially over HTTPS or whatever. But what it is doing is it is unifying your authentication scheme. So rather than having to log into a hotspot using SSID, and then your SIM card is basically your authentication into a cell network, you unify that into something where you have like a Magic global ID, and that will handle authentication into these networks for you. And the software can be used for both provider and consumer, right? So you can just authenticate in and consume that, or you can broadcast out and receive requests to broadcast, or receive requests for data as well. Does that do a reasonable job answering the question?
Yeah, so it seems like it's still kind of like it's software, but
Mm-hmm.
it's like targeting more of like the lower level of the the stacks.
Yes, yeah, it's purely designed to be purely software, and ideally built out for a variety of different types of hardware.
Okay, all right. So yeah, my second question to Ryan. So you did mention that like when you do the different geolocations, one of the things how your protocol differs is that at like every point there's like some kind of like a registry or checkpoint of the information, the geolocation information into the blockchain. Is that correct? Overall,
Sort of, yeah. Sorry.
yeah. So I was just wondering, what is there kind of a way? Is there like some kind of a frequency you can log these data into the blockchain? Like, for example, let's say that 5G becomes more prevalent, and then, for example, we have like autonomous vehicles, and they will like ingest and then like put out like a lot of like data, like information. And I was just wondering, like, the amount of like frequency, like how much of the like the load are you able to insert into the blockchain?
Well, the actual like payload of a LoRa radio, if that's what we're using, is quite small. We're talking just like bytes. And in our case, 90% of the message is actually the public signature. So you just have this like 5% of the message, it's just the timestamp message. So in terms of like messages you're sending over radio, you can only communicate basically, this is my location and my address. And then it's kind of an unknown of what the latency is going to be, of how that goes from like a local zone and checked for fraud and back to another blockchain. So we don't know that kind of latency. But when it comes to actually like a multi-sided marketplace where you have multiple zones and multiple customers, you're going to have something like surge pricing potentially, because the spectrum may be crowded and people are trying to all at once communicate with one zone. They can then basically accept the ones of people offering more money first. And then in our kind of system, we have incentives I haven't gotten into of ways to encourage new coverage in new areas. So when you have this kind of congestion, there are mechanisms to try to offer more.
And last question, I promise I'd come back to you.
So, very simple question. Is it necessary for Internet of Things to exist to have cryptocurrencies? Or like, are they tied together or not? So you certainly need a blockchain for decentralized internet, but do you need cryptocurrencies? Like, how do you envision the payment system? Like, how is that going to work with or without?
Yeah, so in our, like, the foam token is meant to be this work token, so you need it like a taxi medallion to participate, and it gives you governance rights. But if you're a zone operator, you can charge your fees in any token you want. So a stable coin, it could be Ether or something representing dollars. So it's definitely like marketplaces will definitely be driven by currency. But the token that runs this protocol is not a currency.
But do you see the problem where maybe if a cryptocurrency crash happens, it might kill the entire Internet of Things because people will not want to participate. Or
yeah, so I think in general, right? Like when you think about like they are separate but complementary. So like you don't need crypto to do IoT. People are doing IoT without crypto. What cryptocurrencies or what blockchains in particular are good for is decentralized coordination. And that is kind of the core, I think, of what Foam does and what Magic seeks to do. It's like almost as like this new paradigm where rather than having a centralized organization where you take in resources and then dole them out like a corporation, you instead have like a game theoretic mechanism to have large amounts of people coordinating to create a product or service that you can use. And so that's actually almost separate from crypto as like a currency aspect. There are some projects out there that, they may be blockchain based, but they actually don't have a cryptocurrency. They might use something, they might use a stable coin like DAI, or, even just take US dollars if it was programmable. So I think there's like, you can actually kind of separate all three, cryptocurrency, blockchain, and IoT. But there's probably a Venn diagram where they all overlap as well.
Awesome. Great. Thank you, Ben. Thank you, Ryan. Thank you guys all for coming. Thank you, Two Sigma, for having us. Thank you, Ajay, for bringing us in. And I hope everyone has a wonderful night.